Greetings to all my tech heads out there in the KevTechify nation, and if you're new here, welcome. In this episode, we're going to look at IP addressing services. We'll be discussing domain name service, DNS message format, DNS hierarchy, the nslookup command, dynamic host configuration protocol, and DHCP operation. This episode is part of my series on Introduction to Networks for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. One of the main ones we use here for IP addressing services is that domain name service. We take a domain name, a fully qualified domain name. That's what we enter in our web browser. Right here in our example, we have www.cisco.com. We take and we convert that into an IP address because once again, remember, as we send data across the network, we use IP addresses. We use a layer 3 IP address. We don't use domain names. We have to transfer that. We have to change that domain name into an IP address. DNS allows us to do that. What happens here is we take our web browser. In our web browser, we go up here and we type in www.cisco.com. We look at our local DNS cache. In our local DNS cache, do we have an IP address that matches that name? If we do, we can go ahead and start the HTTP request process, but if we don't, we have to go through this domain name service, this DNS process. So we take this domain name and we query our DNS server. The DNS server typically is set up when the IP address information is set. Normally you enter in your IP address, your subnet mask, your default gateway, and a lot of times people enter in DNS servers. That allows us to get our IP address, so we make the query here to our DNS server. The DNS server looks through its records. When it finds the match to that domain name, it sends that IP address back to the client. Now the client has the IP address here that's associated with www.cisco.com. It can now start sending that HTTP request to the web server to get the web page. That's how our DNS works. The format we have for our DNS information here is, we call that resource records. And these resource records, they have different parts to it. It contains the name, the address, and the type of record. Some of these records here, that the common ones here is an A record. What that is an end device IP version 4 address. That's the IP version 4 address of the destination. That was our www.cisco.com. That was the address of the destination web server. That's our IP version 4. That was our IP version 4 address of that server. An NS record is our authoritative name server. That is the DNS server that has the final say in what this address is. Where do I go to look up this information? That's what our authoritative name service is. The quad A, the 4 A's, it's pronounced quad A, that is the end device IP version 6 address. That is the IP version 6 equivalent of just the single A record. So there's an IP version 6 address that is associated with a DNS name. That is the quad A address. And the last common record is the MX. That's the mail exchange record. That identifies the mail server. And what this allows us to do is, because the mail record is a different record, we look at the port number. If the port number, that layer 4 logical port number, is a mail protocol, we use the MX record for the IP address. If it's not, then we use the A record to go there. And that's how we can have Cisco.com on port 80 go to the web server, and then Cisco.com on port 25 go to the web server. If a DNS server doesn't know the IP address to a domain name, it looks to its own DNS server. And eventually we get to one of the root DNS servers. Somewhere along the line, one of these DNS servers is going to know what the DNS equivalent of an IP address is. Now, this has the same message format between the servers. It consists of a question and answer, authority, and an addition. The question is, we're looking for this name server. The answer is that resource record about that name. Then we point it towards an authority, somebody that says, okay, yes, this is the IP address, and then any additional information handled. And every time a DNS server needs to talk to another DNS server, it goes through these 4 steps: the question, the answer, the authority, and the additional information. DNS uses a hierarchical system to create a database of these name to IP resolutions. Each DNS server maintains just a small portion of the DNS system. And if in that small portion of the DNS system, it doesn't have the record for that, it puts that request to another DNS server. The DNS server receives a request for that name translation, and then it forwards it to another DNS server within that proper zone. Some top level domains here, as you can see, the common ones, the original ones were .net, .edu, .com. And then we also have country codes, .au for Australia, .co is another country code out there. And these all work together. And these, once again, are responsible for just a small portion of it. No one DNS has all of the DNS records. Each top level domain has its own main master DNS servers that are responsible for keeping the records, but if you're a .net DNS server, typically you're not a .edu server. When we type nslookup, that basically brings us into another application. We type in nslookup, that gives us some information to start with. Right here is information about what our DNS name server is, what's the IP address of that. So any queries we make are going to start here. When we type in nslookup, we get the greater than prompt. Just like on a Cisco device for user exec mode, here this is signifying we're no longer in just the command prompt, but we are in the nslookup. And from there we can type in different addresses. And when we type in www.cisco.com, it replies back with, this is the domain server that was able to process our request. That was the IP address here of that server. Here is the official name, origin-www.cisco.com, and here's the IP address. We give you the version 6, that's the global unique address, IP version 6, and we also give you the IP version 4 address for that. And we say, here is the aliases of that. And what an alias is also known as name. So the actual server, this is the actual server name. So if you go into the properties of the server, it's going to say this is our actual server, dns-sj.cisco.com, but it's also known as www.cisco.com. We can go in and we type in another one, cisco.netacad.net. Once again, we notice it's on the same server here as www.cisco.com, but what we're looking for is the name of cisco.net, and this is the IP address at which it exists. And so nslookup can help us troubleshoot any problems we have with our name system. I hope you're liking this episode on IP addressing services. If you have the time, please leave a comment and let me know what you think about IP addressing services. You can also visit my website at KevTechify.com for all of my details and how to get these episodes in video and podcast form. DHCP is another IP system we use. DHCP stands for Dynamic Host Configuration Protocol. What this is it is a system that automatically hands out IP addresses on your network. Now, a lot of people use a combination of manually assigning an IP address and using DHCP to dynamically assign IP addresses. Most of the servers, the devices on your network that you don't want the address to change, that would be your servers, your DHCP servers specifically, any of your web servers, your database servers, your default gateways, your printers. Those IP addresses that shouldn't be changing, you go and you manually set those IP addresses. Now, instead of going around to every device and doing that, you only manually set some IP addresses on your network. For the rest of your devices, you use DHCP, because a lot of times you have just a handful. You have a dozen, maybe 24 servers on your network where you manually set that IP address, but you could have 10, 100, or even 1,000 hosts on your network. You don't want to go around to every one of those devices and manually set that IP address. Errors happen. When I type in an IP address, a lot of times I invert numbers, or I lose track of what IP address I'm assigning to what device. And it takes a lot of time. It could take hours and days, maybe even weeks to go in and set this all up. Where you could set up a DHCP server, and that server would make very efficient use of it. It would make sure that the addresses and information got entered in correctly. DHCP for IP version 4 is used quite a lot. Now, when a client connects to the network, one of these that are set up to pull their address automatically, they connect into the network. What we see here is they pull and they look for a DHCP server. That DHCP server responds, and through a communication process, that gives us our IP address. If we look down here at our diagram, we see several examples of where DHCP is used. We have a mobile worker. This person has a smart device connected into a cell tower. That person gets an IP address through the DHCP client. The cell phone company isn't going to come out and set your IP address up there. What they're going to do is set up a server that anytime your device connects to the network, it gets an IP address dynamically. They don't have to worry about it. Down here, we have our corporate network. And if we look here, we have a DHCP server here. This will have a manual IP address on there. But all of these other DHCP clients, this could be out in your office, they're going to be set up to pull an IP address from this DHCP server, making your life simpler, allowing you to do other things on your network, allowing you to make sure that the right information gets set in those IP addresses. On a home network, you have this $50 Linksys Belkin D-Link router set up here, and it runs DHCP for you. Most of the time on a home network, you're going to use DHCP to get your addresses. You pull out your smartphone, you connect into your Wi-Fi at home, you automatically get an IP address there. That's how this is done. DHCP typically is used in IP version 4. DHCP for IP version 6 is called DHCP version 6 is out there, and you could use that. IP version 6 also has dynamic IP version 6 generation of those addresses, and so depending upon your network and requirements, you may use a DHCP version 6 server, or you may let auto configuration for IP version 6 addressing happen. How IP addressing works is when a client turns on and it boots up to the network, it sends out a broadcast. Now that broadcast goes to every device on the network, and it sends out a DHCP discover. All devices on the network hear that DHCP discover, and a DHCP server then replies back to it. So the DHCP hears that discover come in. That DHCP discover is processed by the DHCP server, sends back an offer. That offer is a unicast address. So it is a communication directly between the DHCP server and the DHCP client. It goes right there. And that offer says, hey, I would like to offer you this IP address with this additional information. The client gets that information in, says, okay, that looks good, and then it officially requests that. That request is sent as a broadcast. And we'll talk about that here in a second. This is sent back out as a broadcast. Every device on the network hears the official request to use this DHCP information, this IP information. The DHCP server that sent out that DHCP offer hears that. It then says, okay, you're going to use this IP address. We're going to mark it used in our database to make sure we don't hand it out anymore. And then we send our acknowledgement to the client. The client gets that acknowledgement, this is a unicast at this point in time, so they're directly connecting to the client, and the acknowledgement basically to the DHCP client says, okay, go ahead and use this. Now, this is a broadcast. The DHCP request is a broadcast. Why is that a broadcast? What happens if you have more than one DHCP server on your network? So you have DHCP server 1, you have DHCP server 2, and let's say even you have DHCP 3 on your network. You send out this broadcast, this DHCP broadcast, and it's heard by all 3 of these DHCP servers. All 3 DHCP servers reply back with an offer. They all reply back with an offer. Which one does the client use? The client can only use one of those offers. What it does is it uses the first one it gets in. And let's say the first one coming in was from DHCP 2, the second server. The other 2 offers from DHCP 1 and DHCP 3 are basically ignored. The offer is heard by the client. The client then sends the request back out as a broadcast. That broadcast goes out all the devices here at DHCP 1, DHCP server 2, and DHCP server 3. Here's that broadcast. DHCP 2 responds with an acknowledgement, but DHCP 1 heard that request, DHCP 3 heard that request. What they can do now is say, okay, they are using an offer from a different DHCP server. Let's return what we offered as those IP addresses back into the available pool. This is used because what happens if you have multiple DHCP servers on your network? That's why this request is coming back as a broadcast. Now, how do you remember what this DHCP operation is? We have the DHCP discover. We have the DHCP offer. We have the DHCP request, and then we have the DHCP acknowledgement. We have the discover, we have the offer, we have the request, and then we have the acknowledgement. How do we remember what this DHCP process is? Well, take a look at those letters. We have a D, an O, an R, and an A. This is where Dora the Explorer comes in. It's hokey, but it works. Dora the Explorer, you can remember the D for discover, O for offer, R for request, A for acknowledgement. That's how I remember it. That's how the majority of people remember it out there, is Dora. We're exploring for an IP address. We want this IP address in there. Dora the Explorer is going to find our IP address. We're going to send out that discover. We're going to get an offer back. We're going to officially request it, and then they're going to acknowledge it. Dora. It was my pleasure to provide you with this wonderful episode on IP addressing services. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all of these episodes in video and podcast form. In the upper right is my playlist for my series on Introduction to Networks for the CCNA. In the bottom right is one of my favorite videos that I linked just for you. Thank you so much for watching this episode of my series on Introduction to Networks for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.